Good afternoon. We're looking at 5D question 4, reciprocal 1 on Y transformation. Again, as before, I have my data from the book into the CAS, recreated the scatter plot so I know I've entered the data correctly. I need to linearize the scatter plot by linearize the scatter plot by applying a 1 on Y transformation and fitting a least squares regression line. Again, on list 3, go down to your cal, down here. We need to do a 1 on list 2 this time, because remember, that's our Y values. And what you'll notice is that it's 1, 2, 3, 4, and 5. Now that 0.33 is probably because it should be 0.33333333, but they didn't have room to type it. But never mind. Under here, instead of list 2 for the Y list, we'll use list 3 instead. Draw it. Hey presto, straight line again. Calc, regression, linear regression, Y list needs to be list 3 again. And we get this. A is 6.0606 e to the minus 3. Now again, so one significant figure, So 6.0606 times 10 to the minus 3 that's what that E means. Watch my last video. That means that if I was to write it out fully, it would be 1, 2, 3. So it would be 0.00600606. Well, one significant figure is, again, 0. And B is just going to be 1. So Y equals A plus BX. A is 0 to one significant figure. B is 1. So Y equals X. Now, what transformation did I actually do to it? Well, I did a 1 on Y transformation. So the final equation that you're going to use is 1 on Y equals X. And then it says find the value of Y when X equals 0.25. So 1 on Y equals 0.25. Well, because it's a 1 on Y transformation, what I can do is if I flip this fraction, if I flip my fraction, so if I flip that, what's this as a fraction of? Well, it's over 1. So if I flip this fraction, I can flip this fraction too. So Y on 1 is equal to 1 on 0.25. That means Y is equal to 1 on 4. Y is equal to 4. Now again, you can just go back into your CAS and solve this yourself. Menu, main, solve. 1 on Y equals 0.25, comma Y, and I'll tell you why it's for.